If you saw me at a football game standing like this, wouldn't you think that's pretty odd? Yeah, me too. At a football game, you want to stand like this. It's good! It would be super odd if I was standing like this at a football game. Oh, speaking of the graphs of polynomials, if the degree is odd, that means the graph is going to start down here and it's going to end up here. And if it's an even degree, it's going to start and end in the same place. Oh my goodness. The only way that would change if it's odd and go like this would be if the leading coefficient is negative, because you know that. It reverses it, right? It reflects it. So it's going to go from the bottom to the top, unless it's got a negative coefficient, and then it flips it. Now even, hey, it's good. It starts at the top, ends at the top. Or if the leading coefficient is negative, right? It starts at the bottom, ends at the bottom. All right, so linear, you have seen these with the parent functions. Linear has a degree of 1. It starts in the bottom left and it rises up and to the right. Quadratic, we had all of chapter 2 was quadratic functions. It's a parabola, starts up top, curls down, and then curls back up. Cubic, the third degree, does a little swirl. And this is like the times that they change directions. So this changes directions 3 times. Look, goes up, then down, then up. Quadratic changes degrees twice. It's going down, then up. Linear only stays the same direction, one direction. My favorite band. Quartic, the fourth degree, starts up top, goes down, up. 4 different directions. Starts at the top, ends at the top. Quintic, odd, is going to start at the bottom, but it's going to end up at the top. So it goes up, then down, then up, then down, then up. It goes 5 different directions. It's to the 5th degree. Isn't that fun? Okay. So end behavior is like where the x, what the corresponding y with the x. So as x approaches positive infinity, where does the y go? Does it go towards positive infinity or does it go towards negative infinity? So you would say that for as x approaches negative infinity and x approaches positive infinity. So let's try, we have the graphs here. Like I said, odd degree starts low, ends high. But check out the end behavior. This is how it's listed. As x approaches positive infinity, right? And this is as x approaches positive infinity towards the right. So as it approaches this, p of x, or function of x, or y is also approaching positive infinity. So they go in the same direction. Now it says as x approaches negative infinity, which is going this direction, then y also approaches negative infinity. Great, okay. So when it's an even degree, it's nice, because if you look, the y's are both going up. So as x approaches positive infinity, y approaches positive infinity. As x approaches negative infinity, y still approaches positive infinity. It's still going up. It just flips when the lead coefficient is negative. It just makes those the opposites. So we're going to get into it. We'll talk about the end behavior and stuff here. All right, identify the leading coefficient, degree, and the end behavior. So the lead coefficient is the number in front. So in our case, the lead coefficient would be the -4. The degree of this polynomial is 3, right? So it's a third degree. Now let's keep in mind 3 is odd, right? So ordinarily, odd ones start down here and here, but it's been reversed because our lead coefficient is negative. So as x approaches positive infinity, the y's are dropping down. So we'll say x towards positive infinity. The y's can go in the opposite direction on this one. So So y approaches negative infinity. And as x approaches negative infinity, let me get my arms out again. It was the original, it's reversed. As x approaches negative infinity, the y's are going up towards positive infinity. So it'll take a little bit to get used to that, but you'll be okay. All right, let's try this one. We have x to the sixth. The lead coefficient, the number in front, would just be 1. The degree of this one, this is the sixth degree, which of course is even. So even polynomials go like this, touchdown, right? They start and end in the same spot, and it's positive, so it's going to start positive, and it's going to end positive. So for our end behavior, we'll say, as x approaches positive infinity, y approaches positive infinity. And as x approaches negative infinity, y is still going to approach positive infinity. Because remember, in even degrees, they start and end in the same place, right? So the only way they would approach negative infinity with an even degree is if your lead coefficient was negative. So I'd like you to try 2 here. Go ahead and pause it. Let me move myself out of the way. Make a little room. So pause it. I'll try it out. You try it out. This one's flipped upside down because it's a negative lead coefficient. So as x approaches positive infinity, remember this is upside down. Remember, on even degrees, the y's are going to be doing the same thing. So they're either both going to be positive infinity or negative infinity. Identify whether the function graph has an odd or even degree and a positive or negative lead coefficient. Okay, now, if they're going the same direction, it's even, different directions, odd. So right away, I can see that letter A is going different directions, so it's odd degrees. Now it's starting in the bottom and it's going towards the top. So that means the lead coefficient is positive. That's like the normal way that it goes. Are you sure? I'm positive. This one starts and ends in the same direction, both down, which means it's even. But a positive even degree, touchdown, goes up. So if it's both going down, then that means this would be a negative lead coefficient. So again, try it out, pause it, see if we come up with the same thing. There we go. All right, now we have to take all the information we know here and come up with a general graph. Now this graph is not going to be absolutely perfect, but we're going to need to factor it so we can find the zeros. We can use our y-intercept, and then we'll be able to get a general idea of what the graph should look like. So this is a cubic graph, and the lead coefficient is positive. So it would look something like this, or it might have more of a bend to it. So we know the general graph will look something like this. But for multiplicity, well, let's see if we can factor by grouping. If I group these first two together, They have x squared in common, which leaves us with x plus 1. These have a 1 in common, which leaves us with x plus 1. So we'd have x squared plus 1. Is that right? And x plus 1. Let's get dip into the negative imaginary number system. I feel like I've done something wrong here. X squared plus 1 plus 1 plus 1. Great. Let me see if I can do some synthetic division to find a 0 here. 1, 1, 1, 1. I'm going to need to end up with a negative 1 here to cancel that out. So let me try negative 1, because the only factors of 1 are 1 and negative. So negative 1, 0, 0, 1, negative 1. Okay, so negative 1 is a factor, so that would say x plus 1. And then what's left would be x squared plus 0x plus 1. Now, I'm going to guess this is a mistake in the notes, because our two zeros here, this one would be negative 1. And this one, if we were to solve x squared plus 1 equals 0, we would subtract the 1 and then square root it. And the square root of negative 1 would be I or negative I. We're not going to be able to graph that on our graph, not a normal graph. So we might have to come back to that one. I'm pretty sure there was a mistake in the thing. I'm guessing it was supposed to be x minus 1 to the third power, but we'll be okay. We can come back to that. All right. Now this one, our lead coefficient is negative. It's to the third degree. So our graph would look something like that. Now we're going to factor out the negative. Give us x cubed plus 2x squared minus 9x minus 18. If we were to try to factor this by grouping, these two have an x squared in common, which leaves us with x plus 2. And then this will factor out a negative 9, which leaves us with x plus 2. Great, they both have the x plus 2. So here's what we got so far. We have the negative outside. It would be x squared minus 9. And we have the x plus 2. Now we have a difference of squares here with the x squared minus 9. So that would be x plus 3 and x minus 3. So if we're finding the zeros, we set it equal to 0. So here, x equals negative 3, so that's one of our zeros. Here, x equals positive 3. And then here we have x equals negative 2. So these are going to be the intercepts of the graph. So I'm going to make sure I go at least to negative 3 over here, negative 1, negative 2, negative 3. I'll go to positive 3 as well, just keep it balanced. And it's crossing at these points. Negative 3, positive 3, and negative 2. It's going to be crossing the x-axis at those points. Now we know it's negative, so it's going to start up top, come back around, and then the y-intercept is always the number without any variables on it. So it's going to intercept at positive 18. Now this, of course, will not be to scale, right? Because if this is 3, 18 would be like a mile up in the air. So it's also going to cross up there. So that's enough information to get the general graph. So it's going to start from the top. It's going to dip down, back up. Now, I'm guessing if you saw like a professionally made graph, it will look A, so much better than this, but B, it'll be scaled correctly and it'll look a little more organized. And again, we're going for general graphs. So get the direction of the line, get the intercepts, x and y, and you'll be fine, okay? X to the fourth minus 3x squared minus 4. we can factor this. X to the fourth, usually it was like x squared and then x and then no x's. And you would say like x plus whatever, x minus whatever. So this would just be x squared plus whatever and x squared minus whatever. And again, we're going to run into a problem here because of the imaginary number system. So, factors of 4 that are 3 apart would be 4 and 1. To make them add up to -3, we'd have x squared minus 4 and x squared plus 1. Now we can factor x squared minus 4 still. So x plus 2 times x minus 2. X squared plus 1 we can't do anything with yet. But again, we run into some problems here. Because if you're solving x squared plus 1 equals 0, you would subtract the 1. And then you square root it. The square root of -1, we would say plus or minus I. We're not going to be able to graph the imaginary number system mixed in with the regular numbers. So we're not going to be able to graph this one currently. Well, let's figure out the other x's. So it's also going to cross at -2 and +2. So I guess if we were to get a general graph going, -2, +2, could cross there. Now our y-intercept is at -4. It's also going to cross there. And we have a fourth degree, which is even, which means it starts and ends in the same place. And it's positive, so it means it's going to come from the top and end at the top. So it might look something like this. It's coming down, then it's going to go back up. Now it won't touch the x-axis again for this plus or minus I, because remember that's imaginary number, so it doesn't actually hit the x-axis again. So it's going to dip back down, hit here, come up for positive I. I might have had a little too much curvage on that. 1, 2, 3. Oh yeah, too much curvage. Let me rewind that line. That was a little ambitious. Down, up, then down, then up. Something like that. That's fun, right? It only crossed twice, which is weird because it was to the fourth degree, but remember the other two solutions are imaginary numbers, imaginary complex solutions. So it won't actually hit the x-axis again. That can be a little wild. Let me just check. Okay, this is our last one. Don't be too sad. Don't worry. You still got the homework to do, so don't fear. Okay, it's even, it's negative. So that means it's going to start and end near the bottom. It's to the fourth degree, so it'll change direction. It'll be in 4 different directions. So 1, 2, 3, 4. It might look something like that. We can factor out the negative. Give us x to the fourth plus 4x to the third. Now I see that we don't have an x squared, so I'm going to say plus 0x squared, because we might have to do some synthetic division here. I forgot to change my signs. I'm so forgetful today. It's parent-teacher conferences day. Everyone's favorite day. All right, now if we're testing this with synthetic division, we have 1, -4, 0, 4, -1. Now if we're looking at our last number, -1, we're going to need a positive 1 over here. So the only factors of 1 are 1 and -1, so hopefully one of those will work. 1 times 1 is 1, this will give us -3. Times 1 is -3, -3. -3, 1, 1, 0. Fantastic. So, 1 is a factor. So far we have x minus 1. And then we have some other stuff. We have x to the third minus 3x to the second minus 3x plus 1. Now, if we wanted, we could try factoring by grouping. That's not going to work on this one. So let's keep trying synthetic division. Let's see if we can go a little bit further. We're going to need to end up with a negative 1 over there. So again, let's try negative 1 here. Negative 1 times 1 is negative 1. This will give us negative 4. Times negative 1 is positive 4. That would give us 1. Negative 1 times 1 is negative 1, which gives us 0. So now we have a 0 of negative 1. So we have the x minus 1. Now we have x plus 1. And what's left is 1x squared minus 4x plus 1. Wow. Okay. Now, if we're looking to factor that, what factors of 1 add up to 4? That's not even possible. So what we're going to have to do is we're going to have to bring in the quadratic formula. I know you missed it. X equals plus or minus b, which in our case would be, negative b. I'll write the skeleton here first. So with what we have left, the b is that negative 4. The a would be 1. And the c would also be 1. So then if we kind of just go along here, we have negative 4, which is 4, plus or minus negative 4 squared is 16, minus 4 times 1 times 1 would be 4, over 2 times 1 is 2. 16 minus 4 is 12. Whew, perfect square in 12 would be 4. So we have 4 and 3. Square root of 4 is 2. So continuing this, 4 plus or minus 2 root 3 over 2. Those are both divisible by 2. So it would be 2 plus or minus root 3. Those would be our other zeros. Oh my goodness. All right, so we have a 0 at 2 plus root 3. We have a 0 at 2 minus root 3. Let's go 2, 4, negative 2, negative 4. And then our y-intercept here would be at positive 1, because you see that plus 1 at the end. All right, we got to find some other zeros. Man, this one was rough. So our first x is 1. Our second x is negative 1. Our third and fourth x are this 2 plus root 3 and 2 minus root 3. So at 1, at negative 1, the square root of 3 is like 1 point something, right? Because the square root of 4 is 2. So 2 plus 1 point something would be like 3 point something. So let's call it over here. 2 minus 1 point something would be between 0 and 1. X-intercept is positive, y-intercept is positive 1. Remember, lead coefficient is negative, so it's going to start at the bottom. 2, 3. It might look something like that. That was a rough one. And actually, thinking about the imaginary number system, maybe we should revisit that first graph. But I was like,
no, it's not possible with the imaginary number system.
that is so Mr. Plan. You know what I mean? So neat. We'll graph it. So we have an x-intercept at negative 1. Our y-intercept is at positive 1. And we can just have it go through that point, and the plus or minus I is kind of like the curve in it. So we could say like, oh, it goes up here, never comes all the way back to the x-axis, and then curls up again. That was rough. That was a long one.